Good evening, everyone. I'm Rakhi Yadav, your teaching assistant for course that is Reagents in Organic Synthesis, which is conducted by NPTEL and whose course instructor is Professor Subhash Chandrapan from IIT Guwahati. So, students, if you have attended my last week's tutorial, that is week 1 and week 2, we have covered all the oxidizing based reagents that sir has covered. So from this week we are going to cover reduction based reagents. So before moving to reduction based reagents, let me cover the problems which were left in last class. Okay. So in last class I have given you this problem as a homework. So what will be the solution, students? See, can anyone tell me which one is allylic alcohol among alcohol 1 and 2? Obviously, this one, since this is allylic, right? So, you all know that from previous week's lecture that this reagent is mainly used for oxidation of allylic alcohols, right? So, first, what will form among these two? First, it will form this, right? Now, we have alcohol, we have aldehyde. So 1, 2, 3, 4, 5. And you know that it will form lactol. O, OH, this one. Other things will be same, right? Oxygen, CH2, CH2, yes. Again, this is present in our medium, this oxidizing agent. So this lactol will be converting into lactone. So this is our final product. Is this clear to everyone? Okay. So whenever you get questions like this, first you have to selectively oxidize your allylic alcohol and then you have to make lactol followed by oxidation. Clear? Good. So problem number 2 from last tutorial session is, if you have peroxide written on your arrow, which name reaction is this? This is your Bayer. This is, students, your Bayer Willi. Due to network issue, it is. So, students, if I ask you in Bayer Williger's order, what is the migratory order? So, students, I was asking in bare vinegar oxidation, what was the migratory aptitude order? Electron donating group come ahead of electron withdrawing. Keeping this thing in mind, can anyone tell me? Till that time, let me change my network. Yeah. So, students, if we look at this factor that electron donating should have more migratory aptitude order. So, if you compare between this phenyl and this paramethoxyphenyl, obviously this ring is more electron rich, right? So, in product, and the main thing, bare vinegar oxidation is used for oxidation of ketones to ester. Why? Because you are adding one extra oxygen in that. Okay, so that oxygen will add here since this ring is more electron rich. If we look at left side, this para-nitro is electron withdrawing ring due to the presence of nitro group. So therefore, that oxygen will insert here. Yes or no? So in left side one, oxygen will insert near to paramethoxy ring, and in right side one, it will insert here. Okay. So problem number 3 for today's session is if you if you reduce this N dimethyl aniline with birch reduction condition, what will be the your product? And your options are A to D. Take 0.5 minute time and think over it. Till then, let me write basic mechanism for birch reduction. Okay, this OMe is electron donating group, right? So it, and you all know that sodium is a metal, and metal in the presence of ammonia, metal will do what? It will lose one electron, right? So first radical will form. Why I am making this radical? Because OMe is electron donating group. So you have to make charges away from that, right? Because it can't stabilize carbanion. It can stabilize carbocation. So students, radical, and by combining with this extra electron it will become anionic, and that radical after conjugation will be like this. Yes or no? And now And now, students, once see, I'm giving example for any sol. Same principle is applied here as well because benzene ring is substituted with electron donating group. So, same principle will follow here as well. Now you have protic solvent like ethanol. which will give proton, and again this radical, this metal will give electron to this radical as well, and it will be quenched by your protic solvent, which is ethanol here, right? So what you will get here among A, B, C? A and C you can eliminate by looking at options only. Why? Because birch reduction has nothing to do with this NMe2 group. Yes or no? Right? Now only option remaining is B and D. Now you all know that there are two main conditions for birch reduction. Let me write here. One is if there is electron donating group attached to benzene ring, and on arrow it is given that you are having birch reduction condition. What you will get? One double bond will be just next to that electron donating group, and other will be parallel to it. Okay. And another condition, students, if electron withdrawing group is attached and you are having birch reduction condition. Uh, I have made one mistake here. These bonds will be away from electron withdrawing group. And I hope you know the mechanism. If you break this bond homolytically, radical, radical, right? This radical will resonate and come to this position. And carbon ion will form here, just next to electron withdrawing group. Carbon ion radical, 1 4 anion radical will form, right? It will take proton from your solvent, and at last give electron, one more electron here, it will make carbon ion here, again it will be quenched and you will be getting this benza 1,4 diene. Clear? So whenever you are having electron donating group attached to your benzene ring, make double bond just next to it, like in this fashion. And if you have electron withdrawing group, then you have to make those double bonds completely away from that electron withdrawing group. Plus, they should be parallel like this. They should bonds in birch reduction are not conjugated. Keep this thing in mind, right? Okay. If this thing is clear, problem number four for you is you have this compound. In first step, they have treated it with birch reduction condition in one equivalent H2O, followed by treatment with this allylic bromide gives major product B. Could you please tell me the structure of major product? Take zero point 0.5 minutes time, then I will solve. Okay, finally someone joined. Pooja, can you hear me? Pooja, can you hear me? And are my slides visible to you, student? If my slide is visible to you,
Yes, ma'am.
yeah. Is this first problem was clear to you of birch reduction, or should I explain again?
Ma'am, explain again.
Okay. So students, what I was saying, uh, in birch reduction, what happens is this is your sodium metal. In ammonia solvent, you know that metal have tendency to lose one electron. Yes or no? So whenever you are having electron donating group attached to your benzene ring, these bond will undergo homolytic fission. Radical, radical, right? So at this carbon, this metal will give one electron because radical radical combines and give one electron. One electron pair is having two radicals, yes or no? And another radical which was formed here, via resonance it goes in 1,4 position, right? And at last this negative charge is quenched by proton protic solvents such as ethanol. Again, this will take one more electron from here and will become carbanion here, and that will be quenched by ethanol, and you will get this reduced system in birch reduction. Similarly, I have asked what will be the product if NMA2 group is there. So I said that the option A and C can be directly eliminated as NMA2 is NMA2 group changed to NH2, which is not possible in birch reduction condition. Yes or no? Am I clear to you? You can ask me again. I can again explain. And among B and D, we know that birch reduction product double bonds don't have conjugation. They are isolated. So option B is already deleted. So only correct answer is option number D. And when you have electron withdrawing group, then these double bonds will be away from those electron withdrawing. See, in case of electron donating group, one of the bond is near to electron donating group and one is just parallel to it. In a similar fashion, in electron withdrawing case, one is both will be away and parallel to each other. You can write mechanism. Just you have to break one of the double bond of benzene. Now you may ask, ma'am, which double bond should I break? So students, you know that after getting one electron, it will become carbanion. So carbanion will be stabilized here due to presence of this electron withdrawing group. So obviously in this case you have to cleave this bond, right? Radical, radical. This radical on resonating come here by having one bond here, right? And this radical will become carbanion in presence of this electron. Okay. I hope you are clear.
Yes, ma'am.
See, let me give you more basic explanation for this. For example, carbon is having configuration 1s2, 2s2, 2p2. These are electrons, yes or no? Similarly, these electrons are actually radicals. Radical. One for understanding purpose, I am explaining to you that this one negative charge is equivalent to two radicals. Okay, student. That's why we say this is now filled. This is electron pair. This is your electron pair. Okay. So whenever you are having radical, when this one electron is nothing but your radical. Okay, one electron means radical. Two electron means electron pair. That is your bond. That is your negative charge. Is this basic concept clear to you? That's
Yes,
why
ma'am.
radical radical combining giving carbanion. So if this is clear to you, could you please solve problem number 4? If not, I will solve it next after 30 seconds. Just tell me which option do you think is correct. No issue if you give wrong answer. I will explain to you. Just try. I- Have you taken sir's lecture of previous week? Lithium is equivalent to sodium only, same group. It will give one electron. Is this the most stable form of this radical anion intermediate? Right? This O negative will come back and this negative charge will take this allylic bromide and you will get this. Okay? And this radical will take one electron again from metal, become carbon ion, and will be quenched by this one equivalent water. Right? But now the thing among A and B, which option is more correct as per your hypothesis? In one, they are cis, in another, they are trans. For that, let me make one cyclohexanone. Let's say this is your cyclohexanone. Okay, and if one of the group is above, next group for stability point of view, it should be below or above. It should be below, right? Because above group will be axial to it and it will face severe 1,3 diaxial interaction. Not severe, but from here it will face one of the 1,3 diaxial interaction. Yes or no? So, more appropriate answer is option number B. Are you with me? Pooja, is it clear to you?
Yes, ma'am.
Okay, good. If clear, tell me answer to this. Are there other students apart from you? I hope you all got notification for this class. Okay, Pooja, tell me which option is correct. Okay, here benzene ring have electron donating or withdrawing. First question you should ask in while solving birch reduction. This benzene ring is having electron donating group or electron withdrawing group? Electron donating, right? So whenever you are having electron donating, you have to make these double bonds near to electron donating group but parallel to each other. So A, are you comfortable with this product? Is this correct? A. Now they are adding H plus H2O. What happened? OMe lone pair will come back and they will take this proton. You will be getting double bond OMe positive, right? Then now student make please you can write as your important notes whenever you are having this type of cyclohexane and acidic condition is there. It isomerizes to alpha beta unsaturated ketone. Okay, so correct answer is option number C. Do you have any doubt in this question?
No.
Okay. If not, you should tell answer to this question. Now we have solved enough questions on birth reduction to have answer to this. Just take time and try to answer. All these questions will help you in solving your competitive exam questions as well. Are you solving? Tell me what will be the first step. Student, first step is first you cleave this bond, right? COH dot dot radical, right? Now you have your lithium in presence of liquid ammonia, which will transfer here one electron and it will become carbanion. And now it will isomerize. Now 1,4 radical anion form. Good. Now you have this bromide. This negative charge will knock off this bromide, right? And you will be getting option number C. This radical will become anion and will be quenched by protic solvent. And your correct answer is option number C. Is this clear to you, student? Bache, is it clear to you?
Yes, ma'am.
Okay. So please solve problem number 7. This is again on birch reduction. At least try. No issue if it will be wrong. Just looking at it. Okay, before trying, tell me which ring is more electron rich, left one or right one? Tell me, Pooja, which is more electron rich ring, left one or right one?
Left one.
Left. Wait. This is your left ring, this is your right ring. In right ring, oxygen is giving its lone pair.
Right one.
So it is
Right one.
more electron donating. You know that in birch reduction, metal used to give electron, right? So let's say Ambani come in our village, okay? Will they give money to poor or will they give money to richer? They will give money to poorer person. Yes or no? So if this metal has to give electron, it will give in left side ring, because in right side ring already there is mesomeric effect of this phenol oxygen. Yes or no? Okay. So if this ring has to reduce, obviously these two bonds will be become parallel and this ring will be intact. So correct answer is option number B. Now you understood how I am solving these type of problems. Basically, examiner wants to ask to you whether you know the selectivity. Clear? Okay. Now we are done with birch reduction problems. Let's come to hydride based reducing agent. So, what is the role of LiAlH4?
It is reducing agent.
Okay, so which option is most appropriate according to you? Just try, no issue if you are wrong. You will learn only, right? Tell me which option looks most appropriate. See, just look at options. In option number A, double bond is reduced, but and CHO is intact, which is not possible, right? Because LiLH4 is made only for carbonyl compounds, so it can't leave aldehyde intact. So option A is deleted. Now option B. Is this can be right? This double bond is not a normal double bond. It is in conjugation with this carbonyl as well as this double bond. And if you have taken Sir's last week lecture, he has clearly stated there LiLH4 is used also for reduction of functionalized double bonds. Functionalized double bonds. Right? So, option number C is most appropriate. Have you understood? D is wrong because phenyl ring can't be reduced, right? And in this, everything is good, but this double bond should also be reduced. Clear? Am I not able to explain, Pooja? Is this correct?
Yes, ma'am.
LiLH4 also reduce conjugated double bonds. Okay, you can write it in your notebook. So
Okay.
this chart I have made for you so that your life can be made easy. What you have to learn from this table is whenever you see LiLH4 student on arrow, okay, just scan this slide for 2 minutes. Then we will be solving question based on hydride based reducing agents. Okay, straight. Okay, LiLH4. Why I have written this reagent on top? Because student, this reagent can reduce every functionality nearby to it. Every functionality with I mean that it should be carbonyl compound. Okay, it so from left to right, electrophilicity of carbonyl is decreasing or increasing. Look at it and tell me. From left to right, electrophilicity of carbonyl is increasing or decreasing? For example, you have this COR. If this R group is Cl, chlorine is minus inductive effect, yes or no? So it will make this carbonyl carbon more electron deficient. So that's why it is most it come ahead of all the carbonyl compounds. Therefore, you can see that every reagent can reduce acid chlorides because they are too much reactive. Understood? Then anhydrides come, then aldehyde, ketone. Why ester is not that much? Because in ester OR group is there. This oxygen by its mesomeric effect somewhat reduces the electrophilicity of this carbon. Similarly, in acid there will be OH, in amide there will be NH2. Yeah, from here I was saying electrophilicity of carbonyl is decreasing. But if you look at nitrile and imines, this is your nitrile and this is your imine, right? These are sufficiently reactive, especially iminium ion. Okay. Special feature reduces everything under the sun when it comes to carbonyl compound. Then comes students red L. Red L, you can see that reducing aluminium structure, all these things you can check in sir's lecture. But for now, you should learn here that I will ask you after ending this table, okay? Okay. LiLH4 can reduce everything. Red L is also brother of, or I can say cousin of, LiLH4. One added advantage of Red L is that your LiLH4 is pyrophoric. Pyrophoric means it catches heat, but your Red L is relatively less pyrophoric, or it can be handled easier than your LiLH4. Apart from that, LiLH4 reduces OBN, reduces epoxides as well. So whenever you go through sir's lecture, what you have to do, these are my notes, I have made these notes for you guys, but what you have to do, take sir's lecture of these hydride based reducing agents and you make your own notes that this reagent can reduce till this point, this, okay, so that in exam you can directly uh, choose the correct option. If we talk about sodium borohydride, it reduces till ketone. After that, it can't reduce. Neither it can. If in some worst condition it has to reduce ester, then you have to give high temperature and reagent should be in excess. Okay, this NaBH4 reduces till ketone. Yes or no? Okay. Similarly, Luce's reagent. You know that in Luce's reagent, if you have alpha beta unsaturated ketone, it keep that double bond intact and form allylic alcohol. Okay. NaBH3CN, very much pH dependent reagent, student. It reduces iminium, okay, not imine, at pH 6 to 7. Other than that, at pH 6 to 7, it can't reduce any of the carbonyl. Iminium come ahead of acid chloride. But for aldehyde ketone, pH required is lesser, that is 3 to 4. Okay. Then come LiBH4. LiBH4 is specially made for ester, reducing ester in presence of amide and acid. Okay, that have affinity towards ester. Zinc borohydride. For this order is aldehyde ketoenone ester. Okay. Lithium or case electrolyte, students. You know that Luce's reagent helps to make allylic alcohol, but this is opposite. This is one. This do 1,4 reduction of enones means you will get this product. Double bond will be reduced. Understood? Is this chart clear to you? Should I tell the mechanism of one of the reducing agent? Okay. Before that, let me tell you mechanism also. It will be helpful for you. For example, you have this RC double bond O R dash, and you have LiAlH4 with you. Okay. You know that aluminium is from boron family. Keep one thing in your mind: whenever boron family has three bonds, right? It wants that someone come to fill their electron deficiency, because in their valence shell they have two electron less to attain noble gas configuration. Okay, so what they do, they accept one electron pair. So whenever they accept, it comes negative. Therefore, Li positive, AlH4 negative. Now, if it transfer one of the hydride here, okay, this O negative will, after losing hydride, AlH4 negative will become AlH3. Now again it is electron deficient. Yes or no? So it will coordinate with this O negative. Now again the problem come. If they have three bond, they need someone to quench their thirst. But if they have four bonds, again negative charge will come. Right? Now we have another carbonyl in our reaction medium. Right? Now this intermediate transfers one hydride. Okay. I see. Very interesting mechanism. If you write it by your own, it will be very nice. This student, remember, this transfers one of the hydride here. So after transferring here, what it will form? OAl, H, H, and O, R, R dash. Wait. Oh, sorry. Where is R dash? Again, it is having two hydrides. So, when when you transfer these two hydrides as well, at the end of the day, what it will form? Till this point, is everything clear to you? And now you just hydrolyze this, and you will be getting this alcohol. Is mechanism clear to you? Pooja? Bache, is this mechanism clear to you? You can relate aluminium with boron. Boron is having three bonds. If you recall, BF3, BCl3, and everyone wants to have 8 electron in their valence shell. 1, 2, 3, 4, 5, 6. 2 electron less. So whenever it is having hydrogen attached to it, it become AlH4 negative. Okay. Apart from transferring hydride, student, apart from transferring hydride, if you have this alpha chlorocyclohexanone and you are having alkyne, you will be getting this. Very interesting outcome, but how it will follow. See, this M refers here to as metal. Whenever metal is attached to any carbon, it means this carbon is nucleophilic. M plus, this is negative. For example, your sodium chloride, right? So in presence of metal, it will do nucleophilic addition onto this carbonyl compound and you will be getting this alkyne. Now, in presence of lithium aluminum hydride, it will form this five-membered ring. Okay, this bond will come down and you will get this vinyl alanate, right? After getting this vinyl alanate, you will be getting this six-membered ring followed by hydrolysis. You will be getting this product. This is one extra reaction of lithium aluminum hydride apart from reduction of carbonyl compounds. Okay. If you remember that hydride chart, take zero point 0.5 minutes time and please tell me the most suitable reagent combination of A to C required in the following conversions are. Your options are here. Give zero point 0.5 minute time and try to tell me at least one option among them. Are you solving? See, here you are having enone and selectively you are getting allylic alcohol. So one thing is clear, B is your Luce's reagent, right? So which option have B as Luce's reagent? A and B. So delete option C and D. One thing is clear. Now let's come to C. You know that this is your isolated olefin and this is your enone. So obviously in presence of Wilkinson catalyst, it will reduce this double bond and you will be getting this. So the correct answer is option number A. Is th- is this make sense? Clear how I have approached this problem? Okay. Problem number 10. First, this 2-methyl cyclopentanone is reacted with MCPBA followed by LH reduction. Gives X. Tell me the product X. Can you help me in solving this question, Bache? What is the role of MCPBA? This is metachloroperbenzoic acid, BVO, Baeyer vinegar oxidation, converts ketones to esters. For example, you have R, you have CO, you have R dash, and you know migratory aptitude of R dash is greater than R. So then product will be RCOOR dash. Okay. So here the this bond has more migratory aptitude. So you will be get why because this is your 2 degree, then this is your tertiary. Tertiary comes ahead of 2 degree. You will be getting six-membered ring. Okay. And now LAH reduction. LAH will cleave this lectone and you will be getting option number D, that is diol in your case. Is this problem clear to you? Or should I explain the mechanism of Bayer vinegar oxidation? Bachche, please response. Pooja, is this clear to you? Okay. So for others, let me explain. Let's say you are having this ketone and on arrow it is given you are having MCPBA, metachloroperbenzoic acid. Let me write its normal generalized structure RCOOOH. Among these two oxygen, I have explained it in last tutorial session also, that among these two oxygen, this distal oxygen is more nucleophilic. It will attack here O negative, O OCOR. Okay. R R. Now this protonated OH will transfer its proton here. Okay. Now student, whenever this oxygen will come back, this group will leave and this migratory group will add there. Okay. So at the end of the day you will be getting RCOOR dash. Is it clear to you? So in this way you will be getting Bayer vinegar oxidation product. So next problem for today's session is again, see till if we combine all 3 weeks lecture, in starting 2 week we have covered oxidation based reagents, and now in this week we have started with reduction based reagents. In exam they will not ask you that you should answer from that portion. They will merge them and then make the problems. For example, here first oxidation is happening, right? And after that reduction. So first is again here your Bayer vinegar oxidation, and next is your reduction. Now question comes, do you know the migratory aptitude order? For that you have to see my last week's lecture. And if you look at that, you will be getting oxygen will insert here only. LiLH for reduction, reduce both. You will be getting cyclopropanol as well as ethanol. The correct answer is option number A. Is this problem clear to you? Mechanism wise, I have explained mechanism of both Bayer vinegar oxidation as well as LiLH4 reduction mechanism. Okay. Okay, now comes this question. Student, this question is from your week 3, lecture 3, hydrogenation. So, for hydrogenation students, you must remember that isolated olefins reduce better than your conjugated, and Your without substituted olefin comes ahead of your. Okay. So the correct answer is option number which one? Option number B. This is substituted. Sterically, this is more accessible. Basically, hydrogen absorbs on the surface of this olefin, right, in presence of catalysts such as platinum, palladium, which provides surface for reduction. Correct answer is option number B. Okay, here comes problem number 13. You are having this divine and you are having conditions for birch reduction. Could you please tell me the product? Okay, I have to write options here as they got erased. So for this, option number A is correct. For this, option number D is correct. For this, option number A is correct. For this, B is correct. Okay. So again, student, here you are having two divines. For example, let me write it in generalized form. Okay. If you make radical, one of them will be in anionic form and this will resonate like this. Uh, have I made any mistake anywhere? Okay. And this will be quenched. And again, that double bond will be reduced. So basically, wait, I have done one mistake here. So basically, in presence of birch reduction, students, if you have this alkyne, you will be getting trans alkene as your major product. Okay, and birch reduction is used for conversion to trans alkene. So in option number A, you are getting cis, which is wrong. B, they are trans. Yes, that is correct. C, not possible. D, everything is reduced, which is again not possible. Okay. Can since for since you will attend this lecture later, as there are less students today, but if you know the answer, please write in chat box of YouTube, whichever link you will get. So students, to solve this question, first of all, write in chat box what is the name reaction used for H2 palladium BaSO4. BaSO4 is nothing but your poison cat. What I say is poison. Works here as a poison. This was your famous Rosen Rosenman reduction. Okay. So, after you treat this alkyne with this your Rosenman reagent, you will be getting cis or trans. B is wrong, D is wrong. Generally, H2 based reagent students gives you cis alkanes, and for trans you have to contact to birch reduction. So this is your trans as hydrogen and trans here. So correct answer is option number C. Okay, problem number 15. Take zero point 0.5 minute time and start solving this. Since you don't know this reaction, this is student, you are having diene, you are having dienophile. First 4 plus 2 cycloaddition takes place. COH, COH, both endo. And this class is not for pericyclic reaction, but let me tell you, student, in these type of system, endo is your major product. Endo means facing downwards. Endo is your major product. Okay. After that, osmium tetroxide. Okay, works for diol. So B is your diol. Sorry for my bad handwriting. COH, COH, and you will be getting diol. Okay. In presence of HiO4 student, it will cleave this bond, and you will be getting COH, COH, and here also what you will get HiO4, CHO, CHO. Right? If I'm not wrong. And then excess LH, which will reduce everything, and you will be getting one, 2, 3, 4, 5. Okay, COH, COH, everything will be CH2OH, 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 if I'm not wrong. So, which option is that? I hope option number A is correct. Correct? Or let me write. I just numbered it. Draw 5 membered ring. Again, number it 1, 2, 3, 4, 5. 5 having COH, 1 having COH, 2 CHO, 3 nothing, or I have, yeah, and 4. So all these 4 will be CH2OH. All these 4 will be. So the correct answer is here only, and you will be getting this. So correct answer is option number A. So this is your problem number 16, students. First, the the cyclopentanone is reacted with HCN, followed by LiLH4, followed by diazotization. Very interesting problem, students. If you look at the solution to this problem, please, whenever you are watching my video, pause the video and try to solve by yourself, then see the solution. You are having this cyclopentanone and HCN is there. and you will be getting cyanohydrin compound containing hydroxyl as well as nitrile group is known as cyanohydrin. After LAH reduction, you will be getting CH2NH2. After diazotization, student, this is a very beautiful problem comprising of your name reactions and reducing agents. OH, and this is your N2 disonium chloride, right? Now you know that after, now I'm writing so that you can understand. This is having positive charge here. Now if this bond breaks, this carbocation will be stabilized by mesomeric effect of this alcohol. You will be getting six membered ring converting into cyclohexanone. Yes or no? And correct answer will be option number C. I hope it is clear to everyone who is watching my video. The next problem is about students. Double bond which is most reactive for hydrogenation reaction with Wilkinson catalyst. Student, next question is double bond which is most reactive for hydrogenation reaction with Wilkinson catalyst. First of all, what is your Wilkinson catalyst? RH, PPH3, PPH3, if I'm not wrong, this is your Wilkinson catalyst. Okay, and one of the slide is having that, no? Yeah, RH, PPH here, hydrogen will be this pH. Okay, student. So basically, it undergoes first oxidative addition with H2, right? And then transfers to olefin. But the key point which you should write here, choose least sterically crowded olefin. So basically, this olefin will be more reactive than this. This should be your order. So clearly, by looking at this is deleted. This is deleted. Among four and three, this is more sterically accessible or least sterically crowded. Basically, terminal olefins have more reactivity for reduction. So a correct answer is 4. This question competitive exam from competitive exam point of view, people can ask among this olefin numbered as 1, 2, 3, 4. Basically, this type of question can come in numerical answer type question. There you have to add that number. So correct answer is 4. Okay. The major product of the following reaction is If you have seen my video from starting, you can easily answer this problem. Electron withdrawing group is there. So you will be getting which type of dying away from that group. Okay. So this option is deleted, this option is deleted. Among A and B, one is having cis, as both the hydrogens are same side. This is your cis, this is your trans. So the more appropriate answer is option number A. Correct? Good. So students, in problem number 19, the question is identify the correct reagents required for the following transformation. Okay, we will go one by one. So in option number A, student, okay, before that, let me again tell you how to solve these questions. First, read question clearly. They are asking correct reagents required for the following transformation. Okay, you can tell. Then if you look at option, solve all the option one by one. So if you look at option number A, NaBH4. From that hydride based reducing agent chart, you know that aldehyde is, you from your basic general organic chemistry, you know that aldehyde is more reactive than your ester, and NaBH4 goes for aldehyde. So in option number A, in presence of NaBH4, you will be getting CH2OH. Okay. Then H plus H2O. Okay. Basically, it is acidic hydrolysis, so obviously ester will hydrolyze, not any other thing. But this is not that which has been asked, so option number A gets cross sign. LAH. LAH is like us, can eat anything. Not us. Person who eats both vegetarian and non vegetarian. CH2OH, CH2OH. When everything is reduced, then what is left? Nothing. So B is also wrong. Now there is turn for option number C. Now option number C, student. Again, and let me repeat, aldehydes are more reactive than your ester. So basically, this ethylene glycol is used for protection of aldehydes. Correct? Homework for you all is, please tell me mechanism for protection of aldehydes in presence of ethylene glycol. Very easy mechanism. Again, my pointer is not. Okay, students. So I was saying you have to tell me mechanism for this. Okay, but on hydrolysis, it will again transforms to this. So option number C is wrong. Only correct answer is option number D. But from option number D, you must know one thing. And if you hydrolyze it, it will become CHO, right? And C, you will be getting one CHO, and other you will reduce it by LAH. Okay. Remember, this will hydrolyze at last step after converting. So basically, students, let me take laser pointer here. So basically, this CHO get converted into this CHO gets protected in presence of 1,2-ethane dithiol, right? This CO2 will be converting into CH2OH. So basically, they have written it in opposite way, and these and if you have to do this thing, you may think, ma'am, you will ask me that, ma'am, among these two CHO and CO2 ET, CHO is more reactive. So if you use NaBH4, it will reduce CHO and keep other thing intact, that is ester. But here they want to keep intact aldehyde. That's why they have protected it first in presence of ethane 1,2-dithiol, then reduced it. So this is very beautiful technique if you are doing total synthesis anywhere. Okay. Second last question for today's problem solving session is, how many reagents can carry out the following conversion? This is again very good problem on reagents. First is your diable H. See, one thing is clear, you have to deoxygenate. Diable and all are these hydride based reducing agent. They can't help in deoxygenation, yes or no? So you can delete this option. Now there are two options left. This is your Wolff-Kishner reduction, and this zinc Hg is your Clemenson reduction. And this is your Luce's reagent. It can convert it into allylic alcohol, and in presence of H2PDC, this double bond can be reduced. But here they don't want oxygen here. So you have to consider these two options, option number 2 and 3. First, it is reducing it with H2PDC, that enone. Can enone be reduced in presence of H2PDC? Bit difficult, but yeah, it can be reduced. Sodium liquid ammonia. Yeah, but in birch reduction, this double bond get reduced. So option number 3 is 100% right. Option number 2 can also be right, because if you have in one system you have enone and a isolated double bond, obviously it will reduce that isolated double bond. But since here only one functionality is there, it can reduce, and these two options can be correct. Okay. Okay, last problem for today's session is, I think so, last. Find out the product when this compound reacts with your sodium borohydride. Students, you know very well that sodium borohydride can reduce this, but don't this. So product which is having ester intact and other two functionalities into alcohols. Only option is option number B. Yes or no? The correct answer is option number B. One thing I want to emphasize today is please go through this chart. This chart will be very much helpful for you students. Let me erase all the annotation on this page, which is not possible for me right now. But this chart is very useful for you. What I will suggest, write mechanism of each reagent, hydride based reagent, how they are working, and you should know why from left to right electrophilicity of carbonyl is decreasing. With decrease in electrophilicity of carbonyl, reactivity also decreases. Therefore, we are going from one reagent to another. Now, homework from this slide is you have to tell me in next class why LiLH4 is more reactive, reducing. Reactive means it can reduce everything than your sodium borohydride. Let me tell you factors behind it, but you have to tell me in detail in next class. In your LiLH4, your counter cation is Li positive and below one your sodium positive. Okay. First of all, here aluminium and hydrogen bond is breaking. Similarly, boron and hydrogen bond. So you have to tell me which bond is more polar. Let's say aluminium have more electronegativity than boron, right? And so you have to tell me the electronegativity difference between aluminium and hydrogen, and other is boron and hydrogen. Okay. If not in next class, you can tell me in chat box also. And then you have to tell me, ma'am, why this LiLH4 is more reactive. Okay. And another reason is based on that polarizing power of cations. Read this thing in books. Okay, for the reagent, I will suggest to carry authors. Please go through that book, very nice book, and go through my notes. Everything will be clear for your exam point of view. So, thank you very much, students, for joining the class.